All right, so the first thing I would do is start moving stuff that's negative. So let's move, only focus on what has a negative power. So these two are going to go downstairs, and this one is going to go upstairs. So let's go ahead and do that. So that would be negative 7v to the 8th over 9v to the 6th. So I'm moving the t to the negative 3 down. That becomes positive. The u to the negative 5 is going to come down and become positive. And the t to the negative 7 is going to move up and become positive. So now we only have positive exponents. And we keep going until we have only one of each letter. So right now, I know I'm not finished because do you see how I have V? Oops, meant to highlight. There we go. See how I have the V downstairs and upstairs? I have to simplify that down to 1. And the same thing with T. And we're going to divide these two numbers. So pick up your calculator. Let's do our numbers first. Take the negative 27, divide that by 9. And that should be a negative 3. If you take 8 minus 6, what is 8 minus 6? 2. So I'm going to put those upstairs. And then with my t's, I have 7 minus 3. 7 minus 3 is 4. And I have u to the 5th in my denominator. And that would be your final answer. All right, so let's go ahead and look at question 2. Now, before we do our exponent, let's start simplifying everything on the inside. So the first thing you're going to do is move this down. And I'm noticing that anything with a 0 exponent equals 1, so I'm going to cross that out. So that goes away. So what I'm left with is I have a 2, a y squared, and a y to the 5th. And I'm going to move that x to the power of negative 2. I'm going to move that down and make it positive. So that'll be 2. And then I have x squared. So I'm putting my 2 and my x squared down. I have to subtract these. So when I take 2 minus 5, I actually get a negative 3, which is going to move down and become positive 3. Another way to look at it is when you subtract, you're going to put what you have left over where you started with more. And notice I have more downstairs, so that's why I'm going to put my 3 down, my y to the power of 3 downstairs. All right, pick up your calculator, and now you're ready to square everything inside of your parentheses. So you have 2 squared. So 2 to the power of 2 is 4. And then with your exponents, you're multiplying. Excuse me, thank you. So you're multiplying, and you have 2 times 2, which is 4. So you have 4 x's, or x to the power of 4. And you have y to the power of 6. And that would be your final answer. All right, let's go to our note packet. And we're going to page 14. So the first thing we need to do on page 15, actually, we're going to skip to page 15, is a prime number is a number that only has factors. So let me not say number. So a prime number only has a factor of 1 and itself. So the only numbers that can go into a prime number would be 1 in itself. So an example of a prime number would be 1, 3. The only thing that goes into 3 is 1 and 3. The only thing that goes into 1 is 1 and 1. The only thing that would go into is 4. Is 4 a prime number? Can you divide anything into 4 other than 4? 2, so that means it's not prime, so that would not be. So 5 is 7, 11, and we'll stop there. Composite functions have more factors. So for example, 4, because you can divide 4 by 1, 2, and 4. That's why that's a composite number. 9, because you can divide 9 by 1, 3, and 9. That's why that would be a composite. Or even something like 15, because 15 can be divided by 1, by 3, by 5, and by 15. So that's really important that we know. And one of our most important prime numbers that I should probably put up here is 2. Thank you. So when we simplify a number, because we're going to start building a cake, the birthday cake method to simplify a radical, we're going to divide it by a prime number. So you have to divide it by prime numbers in order to build the cake. All right, so let's go ahead and get started. So this is the birthday cake method. It says step number 1, you're going to start by writing the number as the first layer. Is that somebody else at the door? So you're going to start by writing the number as the first layer, which is 18. So let's go ahead and make that. So somewhere off to the side. And then we're going to divide it by a prime number. So we keep dividing it by prime numbers, Rowan, until we get to a 1 at the top. So a prime number that will evenly divide into the bottom layer until you end up with a 1 at the top. So for example, 18 can be divided by 2. So let's start by dividing it by 2. How many times does 2 go into 18? Feel free to pick up your calculator if you need help.
9.
Did you say 9, Jaden? Okay. So 9 goes here. Okay, can I divide 9 by 2? No? Okay, well, can I divide it by 3?
Yes.
All right, so let's put a 3 on the outside. 3 goes into 9 3 times. 3 goes into 3 1 time. So now I have a 1. You have to keep going until you get to step 6, which is a 1 at the top of the cake. Okay? And then we use the numbers on the outside to write your prime factorization. So that means that 18 can be written as, using these numbers. Another way to write 18 would be 2 times 3 times 3. Now, in order to simplify the radical, we need a pair of the same number. Do you see the same number twice? What number do we have 2 of? We have 2 3s. So that means I'm going to take this pair and they get to come out of the house. I can move that pair to the front, and I only have to write it one time when I move it to the front. So I have a 3 in the front, and then the square root and the 2 left under it. And that would be your final answer. Yes. Okay, let's look at 60. Let's go ahead and build our cake with the 60. So starting off with a 60. I'm gonna go down a little lower because this cake might be tall, so. Okay, so let's take the 60 and let's start dividing it. Let's start by dividing it by 2. So 2 goes into 60 how many times? Pick up your calculator, take 60 and divide it by 2. Can you divide? You keep dividing it by 2 until you can't divide it by 2 anymore. So can I divide 2 into 30? 2 goes into 30, 15. So now we can't do 2 anymore, so we're going to go to 3. Can 3 go into 15? 3 goes into 15 5 times, and then 5 goes into 5 1 time. You keep building the cake. Your cake can have, depending on how many composite factors it has, that's the taller the cake is going to be. So this cake, I need a pair. So this can come out. This comes out. And these 2 numbers have to stay. Because you have to have a partner. You have to have a pair. A pair of the same numbers to come out. So when I make my square root, put that 2 in the front. You only have to write it one time. If you have a pair, we only write it once. And then the 3 times 5 has to stay. And then 3 times 5 is 15. So this is how you would write your answer. And you have to show your steps. Okay, we'll keep working through it. Let's do it. Let's look at 24. Go ahead and try to build your cake for 24. Start by dividing it by 2. Keep dividing it by 2 until you can't divide it by 2 anymore. And sometimes you can divide it by 2 and get to the candle at the top by only dividing by 2. Okay, so I made it to the top with 4 layers. Anybody else have 4 layers? So we divided it by 2, 2, 2, and at the top we had divided by 3. So this cake has 4 layers. So I need a pair. So that means that this pair gets to come out. So I have a 2 that came out. And then underneath the square root, every number that did not have a partner has to stay. So the 2 and the 3 have to stay. So that becomes 2 times 3. So for my final answer would be 2 times the square root of 6. All right. Try to build your cake for 68. I think it only has 3 layers. 68? I think it has 3. Well, are you asking me about this one right here? You already did it? Oh, okay, let's do this one. Yeah, do number 2. So we know that it's even, which means we can start by dividing it by 2. So do you have a pair of the same numbers that can come out? Yep, so see how we have 2 of the same thing? So that can come out. So we got a 2 that comes to the front. And then you make your square root, and this 17 did not have a partner, so it has to stay. So that would be your final answer. You have to show your work when you do these on the test. Okay, we'll do one more. Let's look at number 4. Do number 4. We'll skip over 3. Let's do number 4. Go ahead and build your cake. See how many layers you have in that cake. Show me with your fingers, how many layers did you have? I haven't done it yet, but how many layers do you have in your cake? I see a 7, I see a 5, I see a 5, I see 5. All right, so you started off by dividing it by 2. How many times does 2 go into 72?
36.
Okay, so 36 is still even, so we can divide it by 2 again. So 2 goes into 36 how many times? All right, 18 is still even, so we can divide it by 2 again. So 2 goes into 18 how many times? 9. Okay, so we can't divide it by 2 anymore, but the next prime number we can divide it by is 3. 3 goes into 9 3 times, and 3 goes into 3 1 time. So I do see 5 layers. So a pair, I have a pair of 2s that can come out. I have a pair of 3s that can come out. So I have a 3 on the outside, and I have a 2 on the outside. Make your square root. This has to stay because he did not have a friend. So 1, 2 has to stay by itself. On the outside, when you have, anytime you have numbers, more than one number, we multiply them. So I'm going to multiply that 3 and the 2, which gives me a 6. So 6 root 2 would be my final answer. All right, so the last thing we're going to talk about today is operations. So let's look at number 16. So what we're going to do before we build our cake is multiply it. So pick up your calculators, take 5 times 48. And what is 5 times 48? 240. All right, so we got to make a cake with 240. So this is going to be a tall cake. Go ahead, take your 240, start building your cake. Starting off with 2. So keep dividing it by 2 until you can't divide it by 2 anymore. And then you go to 3, and then you go to 5. But you only want to use prime numbers. All right, show me with your fingers how many layers you have before I... All right, good. 6 layers, good job. All right, so this is what your cake should look like. It's pretty tall. And we got 2 pairs. So I have 2 pairs that can come out. So I have a 2 times 2 on the outside. And then underneath, I have a 3 times 5. So we got 2 times 2. Oh, sorry. Thank you, Alexis.
Alexis.
Trinity, I'm calling you by your sister.
No.
Oh, wait, this is not me. This is next door.
Oh.
It's okay. 105. This is 106. No, 105 is that way. No, it's this way. It's this way. It's this. Yeah, this one. Yeah. Okay, so what's 5 times? Okay, so we got 2 times 2, which is 4. And then 3 times 5 is 15. So that would be your final answer. All right, last one. Go ahead, take 8 times 14. So again, I'm multiplying the numbers. We busy today. Everybody want to come see us. How you doing? Thank you. Okay, so you have, so we're multiplying our numbers. So we have 2 times 2, which gives us a 4, and 3 times 5, which is 15. All right, so this last one, last question. So take 8 times 14. What is 8 times 14? 112? Okay, so let's build our cake with 112. Can I do this without a calculator? Okay, who had 5 layers on their cake? 5 layers? All right. So this was my cake. So I had 2 pairs of 2s. So that means we can take out 2 pairs of 2s that can come out. But the 7 did not have a friend, so it has to stay. So on the outside, I'm going to have 2 times 2, square root of 7. And we multiply that 2 times 2, so my final answer would be 4 square root of 7. And that would be my final answer. Okay, so homework 3, we're going to be working through this last one for quite a while. The only questions you can do right now, because we're just starting, is 1 through 4. Actually, just 1 through 3, because we haven't talked about what to do if it's a variable. So just start with numbers 1 through 3 for today. This is due on Friday. And if you have homeworks 1 and 2 finished, bring them up and I can give you your point.